Good afternoon, students. So now we are going to see about the one more concept, last concept from the unit 4, priority queue. So normally we know what do you mean by priority. So we are going to give the preference. So already the same topic we saw in the stack operation. What is the operation we saw? That is infix to postfix. So the highest priority, whenever highest priority operator will come, we can do this thing. Whenever lowest priority can come, we do this thing. The same priority come, we are going to do this thing. So everything we saw in the stack, right? Same like priority queue, we are going to see it. So priority means nothing but you should remember the word called preference. So depending upon the element, we are going to give the preference. Suppose the highest priority element came, then we can tell that is d cube before an element with the lower priority. So next one, if suppose both the priority in the queue, one priority that is having fifth priority, and the elements you are having in your hand that is also 5, that is the same priority, means you are going to dequeue according to their order. So here it's the same thing, whatever you followed in the stack, the same thing we are going to follow it here. For example, here we can do NQ operation, that is insertion, DQ operation, that is addition. If you want to NQ and DQ it, we want to check it. So here the priority, for example, I am giving the element called A, B, C, D, E. So I am giving the priority 7, 4, 2, 1, 3. So here you should not consider the highest number is the first priority. No, this is ranking. So here which is the highest priority, which is the first priority, means that is D is your first priority. So one thing you remember, higher number lower priority, lower number higher priority, like that you can remember it. Okay. So higher number means lower priority, lower number means higher priority. So here the first priority we are going to the D and the second priority we are going to the C, like that depending upon the ranking. So simply you can think it as this is ranking. Okay. So depending upon this we are going to give the priority. So two operation we can do, it may be we can do it in ascending order or descending order, it is your wish. So next one, implementation. So normally in stack we can implement the stack using array and the linked list concept, right? Same thing here, if you want to implement the priority queue, you can use the array concept, linked list concept and the heap concept. So now depending upon your syllabus we are going for the array concept. So here an array means what? Collection of a similar data types. With the help of the array we are going to give the priority queue. So for example, so now we are going to see about the NQ operation. So already said we are need to insert means NQ, if you want to delete is DQ. To do this performance we need to check it, okay, depending upon the priority. So here for example I am going to give the elements in the array. I am going to give the elements A, B, C, E. So this is your element. The next I am going to give the index 0, 1, 2, 3. Next I am going to prefer the priority 1, 2, 3, 5. For example, I am giving like this. So I want to do here, first one is NQ operation. So I want to insert an element that is ELE called D. So their priority I am going to give is 4. So this is the fourth priority, element I want to insert is D. Depending upon the priority it will insert in the particular place. So for example, the first one you should check it. For example, in this I am giving the size equal to 4. This is what count? This is nothing but your human count. Human count meaning is what? 1, 2, 3, 4. Totally 4 size we need it. Here if it is 4 sizes filled, 0 to this is nothing but what? Machine count. If it is already filled, so what will happen? It will give you overflow. So meaning is what? If your rear size is greater than size equal to -1. So what is meaning? Says this greater than or equal to. Rear is nothing but how much? So we already know this is your front position. This is your rear position. So rear is 3, greater than or equal to 4 minus 1 is 3. It is equal to, so what do you mean by this one? Overflow. Suppose in mine I am giving the size is 5. Again it is nothing but the human count. Now what we are going to do, we can able to insert. We have a one more position we can able to insert. Before that, suppose I am giving an example like this, nothing should be there, okay. So front equal to -1, rear equal to -1. So meaning is what? There is an array with the size of 5 but nothing, the element should be inside. So what we are going to do? Make front plus plus equal to nothing but what? Front equal to front plus 1. Same thing for rear. Rear plus plus means rear equal to rare plus 1. So, I am increasing. So, what will happen? Automatically there is a 5 size. The friend and rare position will point towards a single array. This is also friend, this is also there because nothing should be there. Now, we can insert your element. X is your element. For example, I am determining X equal to D. So, we can insert in the particular position. That is nothing but what? PQ of rear equal to X. So, I already said Q concept where we can able to insert only at the rare position. There is a line P1 to Pn. So, they are getting the tickets one by one. If you want to add insert n plus 1, we can insert it only in the rear position. So, this is the line we are going to do it. Suppose for example, we are getting like this. So, what will happen? Now, we are going to check according to the priority. So, now we are going for check operation. So, what we are going to do here, check operation. So, in the check operation, first one we should check from the for I equal to 0 to rare. So, for example, according to the question I gave A, B, C, E and one more thing is there. This is your index, this is your priority. So, I want to insert number 4, their priority, insert number D, their priority is 4. Now, what we are going to do here, first one I equal to 0. So, now we are going to check the data. So, data A greater than or equal to your priority Q of 5. Just check the data, data is D greater than PQ of 0. It's that greater? Yes. According to the data, what is the priority? 4. 4 is greater than or equal to PQ of 0. 0 is the first priority. It is nothing but the first priority. So, we are going to keep some this greater. So, now what we are going to do? Now, we are going to use the J loop. J equal to rear plus 1 to 0. Meaning is what? Already the rear position is here 3. Here this is your front position. So, J equal to 3 plus 1 to 0. We are coming from the last to here. So, what will happen? J equal to 4 to 0. So, what will happen now? We are going to do this condition. PQ J equal to PQ J minus 1. So, what is J? Initially J equal to 4. So, what will happen here? I am going to keep PQ 4 equal to PQ 4 minus 1 3. Whatever you are having in the 3, that I am going to keep it in the 4. That is what the meaning. This is assignment. Whatever you are having in the third index, we are going to put it in the fourth index. So, what will happen? Automatically, this will comes to here. Nothing should be there here. So, next one what we are going to do? So, now PQ, what is your I? At last, what is the I position we are getting? I equal to so, we are going to keep on moving. So, whenever you are getting that particular position, so already I said there is a priority in the D is 4. So, this is nothing but the priority will go there. So, if I am checking this, this is less than this priority. So, until this condition satisfied, we are going to keep on moving. Now, with the one moving itself, we are getting the value, right. So, now we are going to make your element to the particular index. Third index. This is nothing but the third index. So, what we are going to do? So, simply we are going to assign PQ of I equal to your element called D. In the position of 3, that is in the index of 3, D will be sitting. So, this is how we are going to insert an element. Next one, we are going to delete the priority Q. For example, if we are having the same thing A, B, C. This is your index, this is your priority. For example, I want to delete number B. So, this is in the third priority, that is second priority according to the given question. The first thing you are going to check whether there is a element should be there inside the array or not. If it is not, it is showing front equal to minus 1, rear equal to minus 1. So, what will happen? Automatically it will print out under flow. Okay. So, according to this, there is an element should be there. It indicates front and this indicates rear position. So, now what we are going to do? I equal to 0 to rear. So, what will happen? First initially I equal to 0. So, your data you want to delete the data called, I already said, number B. So, B, that is third position. If you want to delete, if it is equal to your index. So, meaning is what? I equal to 0 or no? I equal to 1 na? Yes. So, automatically what will happen? So, P of 3 equal to PQ of 1. We got the position. Now we are going to introduce the j loop, j equal to I to rear. So actually I is what? I equal to 1. 1 to 2. Rear position according to this condition is 2. What will happen here? So PQ of 1 equal to PQ of j plus 1. Meaning is what? This is j. Sorry, j. So PQ of 1 equal to PQ of 2. So whatever you are having in the 2, that should be keep it in the 1. So I am having 2c. So that should be keep it in the c. Automatically the b will be overwritten by 4. So automatically the rear position will be minus minus. So what will happen? Initially rear equal to 2. Now it become rear equal to 1. Automatically it will comes here. So now we have AC 0 1. This is how we are going to delete in the priority queue.